Sampling distribution of the sample mean. The sampling distribution of the sample mean is a distribution of all possible sample means, or the distribution of the variable there, with all samples having the same sample size n taken from the same population. The sampling distribution of the sample mean is typically represented as a probability distribution in the format of a probability histogram, formula, or table. The behavior of sample means. The distribution of sample means tends to be a normal distribution. This will be discussed further in the following section, but the distribution tends to become closer to a normal distribution as the sample size increases. The sample means target the value of the population mean. That is, the mean of the sample means is the population mean, and the expected value of the sample mean is equal to the population mean. So let's take a look at example 2. Sampling distributions of the sample mean. A friend of the author has 3 children with ages of 4, 5, and 9. Let's consider the population consisting of 4, 5, 9. If 2 ages are randomly selected with replacement from the population of 4, 5, 9, identify the sampling distribution of the sample mean by creating a table representing the probability distribution of the sample mean. Construct a probability distribution table that describes the sampling distribution of the mean of the given numbers when samples of sizes n equals 2 are randomly selected. Do the values of the sample mean target the value of the population mean? In part A, it says list and identify all the n equals 2 possible samples of 4, 5, and 9. Well, we have 4, 4, 4, 5, 4, 9, 5, 4, 5, 5, 5, 9, 9, 4, 9, 5, and 9, 9. So we have a total of 1, 2, 3, 4, 5, 6, 7, 8, 9 samples of n equals 2. Now we want to find the population mean of 4, 5, and 9. So if we take 4 plus 5 plus 9 and divide it by 3, we get 18 over 3, and therefore the population mean is going to be 6.0. Now in part C it says find the mean of the numbers of each of the 9 samples, and then summarize the sampling distribution of the sample mean of the numbers in the format of a table representing the probability distribution of the distinct mean values. So we begin by finding all possible sample means. Find the mean for each sample and note that the probability of each sample is 1 out of 9 because each of the 9 samples are equally likely. So for the first sample, we know that it was 4, 4. So the sample mean is taking 4 plus 4 and dividing it by 2, since we want to find the mean of those two, which is equal to 4.0. Probability of that happening is 1 out of 9. The next two values are 4 and 5, so we want to find the mean between 4 and 5. 4 plus 5 divided by 2 gives us 4.5, and the probability of that happening is 1 out of 9. Next we have the sample of 4 and 9. We're going to find the mean of those two values. So 4 plus 9 divided by 2 gives us 6.5, and the probability of that happening is 1 out of 9. The next we have 5 and 4. If we take 5 plus 4 and divide that by 2, that gives us 4.5, and therefore the probability of that happening is 1 out of 9. Next we have 5 and 5. So we're going to take 5 plus 5, divide that by 2, that gives us the mean, which is 5.0, which that probability is 1 out of 9. Next we have 5 and 9. 5 plus 9 divided by 2 gives us 7.0, and the probability of that happening is 1 out of 9. Next we have 9 and 4. So 9 plus 4 divided by 2 gives us 6.5, and the probability of that happening is 1 out of 9. 9 and 5, 9 plus 5 divided by 2 is 7.0, and the probability of that happening is 1 out of 9. And then last we have 9 and 9. 9 plus 9 divided by 2 gives us 9, and the probability of that happening is 1 out of 9. So now we want to find out all the values that represent the sample means. So the first sample mean that we have is 4.0. So how many do we have of those? We only have one of them, and the probability of that happening is 1 out of 9. So we would say the probability of that happening is 1 out of 9. Okay, the next sample mean is 4.5, and how many do we have of those? 1, 2. So that means we have 1/9 plus another 1/9, which is going to give us 2/9. Next, we have the sample mean that represents 5.0. So if we come down here, we only have one of those, which means the probability of that is just 1 out of 9. Next, we have 6.5. We have 1 and we have 2. The probability of that is 1/9 plus 1/9, which gives us 2/9. Next, we have 7. So how many 7.0s do we have? We have 1 and we have 2. So 1/9 plus 1/9 is going to give us 2/9. And then the last one, we have the sample mean of 9.0. And so we only have one of those, which is 1 over 9. So therefore, the probability of that represents 1 out of 9. So there is the completed table for the probability distribution shown below. Now in part D, it says find the mean of the sampling distribution of the sample mean of the numbers. So that means we need to add all the following numbers and divide it by 9, since there's a total of 9. So we're going to add all of these numbers, which you can see here as an enumerator. The mean of the sample means is 4.0 plus 4.5 plus 6.5 all the way to 9.0 and divided by 9, which gives us 54 over 9, which gives us 6.0. So that should tell you that it compares to the sample mean that we found in part B of the population mean. So the mean of the sample means is 6.0, and now the question is asked, do the values of the sample mean target the value of the population mean? Now, if a sample statistic targets the value of the corresponding population parameter, the sample statistic is an unbiased estimator. That is, the sampling distribution of the sample statistic has a mean. If a sample statistic does not target the value of the corresponding population parameter, then the sample statistic is a biased estimator. A biased estimator systematically underestimates or overestimates the parameter. In this case, the sample means target the mean of the numbers in the population. So sample means make good estimators of the population mean. So here's the interpretation. Because the mean of the sample mean 6.0 is equal to the mean of the population, which is 6.0, we conclude that the values of the sample mean do target the value of the population mean. And this illustrates the mean of the sample means is equal to the population mean. Now note that if we were to create a histogram of this example, it would not have the bell shape that is characteristic of a normal distribution. But that's because we are working with very small samples. If the population of 4, 5, and 9 were much larger, and if we were selecting samples much larger than n equals 2, we would get a probability histogram that is much closer to being bell-shaped, indicating a normal distribution.